In this session, we want to look at factoring as an area problem. Let's look at how multiplication works. If we multiply 12 times 17, we can think of that as 12 groups of 17 or 17 groups of 12, because multiplication is commutative. If we think about it as 12 groups of 17, then we have a rectangle that has 12 rows and 17 columns. So 12 rows and 17 columns. Now we can count how many tiles are in this rectangle, or we can group it in a clever way. If we think about 12 as being 10 plus 2, so there's my 10, and then there's 2 more down here. 10 plus 7. So we think about this as a 10 by 10 square, and then a 10 by 7 rectangle, and a 2 by 10 rectangle, and then 14 individual little tiles. That's 2 rows and 7 columns. 2 times 7 is 14. So we have 14 little spaces over here. Group these cells together as a single object. This first rectangle is 10 by 10, which is 100. 10 times 10 is 100. The second rectangle was 10 by 7, and 10 by 7 makes 70. The third rectangle was 2 by 10. 2 times 10 is 20. And then the fourth piece of this rectangle, we have 2 rows and 7 columns. Altogether there are 14 little tiles in that fourth part of my rectangle. If we count the area, we have a total area of 100 plus 70 plus 20 plus 14 makes 204. So we have 12 times 17 is 204. Using the regular way to multiply, 12 times 17, well, 2 times 7 is 14, and we carry the 1. And then 1 times 7 is 7, plus 1 makes 8. And then we shift down and move 1 column over. 2 times 1 is 2, and 1 times 1 is 1. And when we add these together, we get 4, and 8 and 2 make 10, and carry the 1 over, and 1 plus 1 is 204. Now let's take a look at this 14 piece right here. 14 is 10 plus 4, and that 10 and this 70 make the 80 that you see here. And so it is consistent with the way we multiply. Furthermore, if we write 12 as a binomial, we can write 12 as 10 plus 2, and we write 17 as 10 plus 7, and using the distribution property, we FOIL. The first terms, 10 times 10 is 100. The outside terms, 10 times 7 is 70. The inside terms is 10 times 2 is 20. And the last terms, 2 times 7 is 14. So we have a consistent way of looking at this multiplication problem in terms of area. The exact reasoning can be applied to multiplying things like x plus 7 with x plus 2. If we apply the distribution property and multiply the first terms together, we get x squared. Multiplying the outside terms, 2 times x, we get 2x. The inside terms, 7 times x, we get 7x. And the last terms, 2 times 7 is 14. And now when we collect like terms, we end up with x squared plus 9x plus 14 as a solution. If we think about this in terms of looking at area like we did before, and if we let x represent a rod that has side 1 and length x, so this is a 1 by x, then the area of that rod is x. And now let x squared represented by a square of side x, then we have a square that has area x squared. And we let the unit be a 1 by 1, the area of that tiny square is 1. When we have something like x squared plus 9x plus 14, that means we have one of those squares, x by x. We have 9 of the little rods of size x. We have 9 of them. And we have 14 little 1 by 1 squares. And the goal would be, can you rearrange one square, one flat, 9 rods, and 14 little tiles to form a rectangle? If it factors, we will be able to do that. If this piece right here represents the x, and this piece right here represents length x, then there's my flat with area x squared. Now, if I have a unit here of 1 rod, and another unit here of 1 rod, here's 2, and the side would be x plus 2. Now going the other direction, I'm going to count out 7 little units. Here's my first unit, 1. The next unit over here would be 2. And then I have 3, 4, 5, 6, 7. So the area would be 7x. And the area down here is 2x. And the length of this rectangle on top would be x, and then plus 7. And finally, the fourth little quadrant is formulated by having little tiles, which is 7 columns and 2 rows. There are a total of 14 little pieces. So altogether we have 1x squared plus 9x plus 14. And if we look at that 9x in terms of 7x and 2x, then when we group the first two terms together and factor out an x, we have x and an x plus 7 left behind. The next two terms we can group together and factor out a 2, and then there's an x plus 7 left behind. And now you see that we have a binomial factor in common, so the x plus 7 can come out, and what's left over would be x plus 2. And we have factored x squared plus 9x plus 14 in terms of x plus 7 and x plus 2.